Greetings and salutations, fellow YouTubians. My name's Terry Andrews Jr., also known as the J5 Guru. Today I'm going to attempt to answer some questions and explain some things about the Eccentric drive and the assembly location, the proper location of the master link within the Eccentric drive, accessing the adjustment potentiometer, different things like that. First of all, how do I access the potentiometer? It's covered up by the track drives. There are two positions in which that is accessible. One is the lowermost position, and in order to access it, obviously the accessory cover gets in the way. Remove that accessory covering, okay? Then you can access that that potentiometer, that slot in the potentiometer. Okay, so the other one is in the full up position. So I go here, I'm doing a sectional view. Okay, so you can see the track is there. And if I go ahead and I articulate this to the full upright position, right here, we hit about the dwell point, you will see that you have to remove the tracks in order to access that slot, okay? So, yes, you need to remove the tracks there. Okay, so, as not to confuse SolidWorks, I'm going to go back here, going to re-show that. You can see the tracks are, yep, they're in the way, okay? So you can't have the tracks there, but you can access that in the full upright position and the full lower position. Now, if you have removable tracks, this is not an issue. You simply remove the tracks and then do your adjustments without the tracks on. That is actually the preferred method and the way the system was designed. So, there's that. Alright. So I go down here, I'm going to try to hide all of this now. Okay, so all of that's out of the way. We go back to our sectional view. So we'll get a straight on view here. So the eccentric drive. Now ideally what you want to do is you want to do all of these adjustments with the eccentric drive not even in the robot. You want to do your baseline configuration and adjustments without this even in here, and you actually only need one half of the eccentric drive. You need the drive side, okay? The other side over here, that's just a follower. So when you do all these adjustments and you're tweaking and things like that and adjusting your code or your servo amp or whatever, do yourself a favor, don't do it while it's in the robot. The only reason that one would need to access this for adjustment is if there's been basically an accident, a wire to the potentiometer has come off, or there's been a software error, and for whatever reason this thing has become out of time because it's been allowed to keep rotating in a particular direction. And now the sprocket, this sprocket, and this potentiometer are now out of time with each other, okay? In which case, you're going to have to go through some steps to recalibrate things, and it's going to be a pain in the backside. It is what it is. So, let me get this, make sure this is squared up to us again. Alright, so how should this operate? Okay, you have two choices here. Do you want this to rotate anti-clockwise when raising, or do you want it to raise clockwise? Rotate clockwise when raising. The answer is clockwise, okay? So this is going to be your start position, okay? Let me see if I hit the dwell point. Right there's the dwell point. The dwell point is the position at which everything basically locks up. There's no forward or backward movement of this cam in relationship to this sprocket, okay? It's a self-locking mechanism. So you want to rotate clockwise, okay? And it will end up over and about here, okay? Yep, right about there is the dwell. Your master link, this is currently catted down here in the wrong position, and it is in the wrong orientation, which is to say that this clip should be facing inward to the robot. So it should actually be on this side, okay? The reason for that is that the master link itself, the pins stick up higher on the master link because it has to accommodate this clip. Those longer pins actually go into the metal, okay? Your 1/4 inch outer plate, they actually go into that, okay? You can see where these pins sit much lower, okay? This pin much higher. That is bad. We do not want that. And remember, this is CAD world, so everything is, centered and precisely aligned and all that other good stuff. In the real world, things have rock and roll. So this chain can actually go over even further, okay? Now, we already know that these pins can and will rub against this metal plate. There's no avoiding that. It is what it is. We were constrained by the physical volume and shape and structure of the original robot. We just couldn't change things to accommodate certain things. So we've got that. So if we flip this master link over, we now have the same problem on this side where this arm and these pins, the top of these pins, will hit. Okay, so we've got there and there. Okay, there's not a lot of room there. Okay, so we have to keep the master link from crossing over this area. Okay, that's very simple. It's a matter of putting the master link in the right place and only rotating in one given direction. Since this only rotates 180 degrees, we use that to our advantage, to where if we put this master link up here, okay, so I would use this bearing in the motor as kind of your home spot, okay? So say like right here, okay? So your master link's going to go in there. So this way, when you rotate this in a clockwise direction, this master link will now travel down in this direction, around this pinion, and it will end up somewhere down around here, okay? So it's never in any of the spots where it could possibly cause a problem, okay? The other reason you want your master link up here on top and the clip facing the inside is you want to be able to access, to see that clip, to make sure over time it hasn't fallen off, and, something's worked loose, something bad has happened, okay? If you put it anywhere else, it's going to, like down here, it's impossible to get to. You got to take the whole robot apart to get to that master link. Now, the caveat here is that even with the master link being up here, in the orientation it is in, you cannot remove that master link without removing the entire eccentric drive from the robot. okay, from the cradle base. Again, this is what it is. I'm sorry, folks. I'm, I'm not a magician here. This was very challenging to get all of this to fit. And a lot of you will go, well, why didn't you simply use a smaller output sprocket here? You couldn't do that. In order to get the physical stroke needed, the physical linear travel needed to get the tracks to move the angles that they had to move, the amount, this is the size. This is where this eccentric cam has to be. You go with a smaller sprocket, well, now these links now hit into here. It's just a domino effect. You make one small change and it affects everything else. We couldn't go with a smaller sprocket here. We couldn't go with a larger sprocket out here. Everything barely fits. Okay. We couldn't really change the size of this sprocket right here. That's the reason we have a 3-turn pot in here, because a normal potentiometer only rotates, has a maximum rotation of about 300 degrees. We needed more than that, which is why you have a 3-turn pot. As far as adjusting this, yes, it's going to be a pain in the backside. So, when you go to calibrate this or set this up, keep in mind, this is not the center position. This is not the center position. These are the two end points, okay? I think what's happening when people are trying to calibrate things, they're getting two possible things can be wrong. One is that the motor is rotating in the wrong direction, okay? So they're commanding it to go one way, and it's actually going the opposite way of what it should be. So change that either in software or reverse your motor lead so that the motor rotates in the direction that you're commanding it, the correct direction, okay? So if you're commanding this to turn clockwise, make sure that the motor is actually turning in a way that will turn it clockwise, okay? The other thing, you could have the potentiometer leads reversed, flip them around. Flip those two end leads around. That will change things for you. So I think that's tripping people up. The other thing that I think is tripping people up is, remember, in software, or if you're using a transmitter, to test this or set it up, when you're calibrating this, you need to calibrate for the low end point, like here. This is at the low position. So if you are starting your calibrations in the mid position, well then obviously this thing is not in the mid position. This would have to be in the mid position, which would be somewhere in here, which, number one, is kind of difficult to figure out exactly where the midpoint of travel is. And number two, if you've got the tracks on, well, guess what? You can't access this. The tracks are in the way. Okay? So you can't do your fine tuning here. So again, I would suggest that you do all of this, you have your eccentric drive on the bench and find that dwell point, maybe you can have it in the cradle base, without all the other stuff, but yeah, it's going to be a pain, but this is a one-time setup. Okay. Once you have this set up, unless there is some sort of a catastrophic issue, you should never have to recalibrate this again. Okay. Now, with that being said, let's say you have a wire come off of the potentiometer and this thing gets into a condition, it starts spinning. Okay. Well, at some point that 3-turn pot is going to hit its end stop, which is why that this sprocket must be loose on this potentiometer shaft. Otherwise, as one builder has discovered, yeah, it will over-rotate that potentiometer and destroy the potentiometer. So it needs to be a loose fit on this shaft, this sprocket, okay? Do what you need to do. Put a piece of yarn in here, a piece of string, something, so that it, if it does over-rotate, the potentiometer shaft can stop, but still allow this outer sprocket to spin. In which case, then, you figure out what the problem was, fix the wiring, fix the software, whatever it was that caused it to over-rotate, and then you have to go through your calibration procedure, which is why there's the access point. So hopefully you don't have to take the entire robot apart to reset everything. So yeah, that's the long and short of it. You do not want to rotate it this way, because if you have it rotating this way, that now means that this master link has to be at the bottom, which means you're not going to really be able to get to it unless the tracks have been rotated, all the way up, and then the track's in the way. Yeah, consider this clockwise rotation of the eccentric drive to be canon and to be the official rotation of the eccentric drive for the track tip. So I hope I've answered everything. I know it's not a perfect system. It's not a perfect world. We do what we can. I came up with a basic idea and concept of this based upon, what I seen growing up on a farm with farm implements that ran off of simply mechanical inputs. There was no, linear actuators or anything like that. This thing needed to be bulletproof, which it is. And honestly, the weak point is the electronics, the potentiometer, the wiring, that's, that's its Achilles heel. So by all means, try to be sure that these wires never get caught up in anything. Eventually the potentiometer may start to fail on you. If you see that, yeah, replace it immediately. Again, it is what it is. So there you go. Terry Andrews Jr., J5 Guru, saying bye for now, and I hope this explanation helped you out. Alrighty, have a good one.